I trust that we are back now. And ready to start. Okay, I trust we are all back and that we are ready to start. Okay, the second question that I want us to look at, or the last question in this volume story, before we go into our chairs, is this particular question that we were looking at just before the break. See, the cone of Earth's radius r, sorry, and AB is inscribed in a sphere with center O and radius of 8 centimeters, and O is x. So if I read it correctly, is I've got the sphere, and I've got my ice cream cone inside of it, right? And they tell me that the height AB, it goes from the center. So if I'm just looking at the sphere, what is the radius of the sphere? Do they tell me? Yes, the radius of the sphere goes from here to here, so that's 8. And from there to there, it's also 8. Okay? Radius of my sphere. If I look at the cone, then this length here is the height of my cone. Okay? So AB is the height of a cone. So if I want to know what the length of AB is, it will be the radius of the sphere plus that little bit, x. That will give me the height of my cone. Right? They give me my formulas, and now I can carry on. So let's see what they want us to do. Calculate the volume of the sphere. So I've got my formula, and all I need is to know the radius of my sphere, which I do have. So, see. Let's go back. Okay. So I would like the volume of the sphere. So let's see. Volume of my sphere. So what is my volume formula? My volume formula happens to be 4/3 pi r cubed. Now, remember when we spoke about the sphere? We spoke about the sphere as being, well, if I think about it, there's my sphere, and they told me the radius is 8. So that line drawn from the center to the circumference happens to be 8. So that's my sphere, the radius of my sphere. Now, it's not exactly round. Sphere is a little bit elongated like a rugby ball, so the radius is 8. So all that I needed to do is just to substitute pi at 8 cubed, and then I ended up with my volume. So my volume happens to be 2144,66. Okay? And it is centimeters cubed, because this whole thing is in centimeters. All right. Number 9.2, they asked me to find the radius in terms of. Show that the radius squared is equal to 64 minus x squared. Now, can I find the radius? Now, let's have a look at my sketch very carefully. If I look carefully at my sketch, I've got a little right angle triangle where the length here is x. We know the line drawn from the center to the circumference was 8, and this is r. So they wanted me to prove the radius squared. So if I use Pythagoras Theorem, then Pythagoras Theorem says what? It says the hypotenuse squared is equal to the opposite side squared plus the adjacent side squared. Hypotenuse in this case is 8. My opposite side happens to be x. And my adjacent side happens to be r all squared. So, 64 was equal to x squared plus r squared. So, 64 minus x squared was equal to r squared. And that answers my question. Determine the ratio between the largest volume of this cone, that's the next question, and the volume of the sphere. So 9.3. Let's go there. Look at 9.3. What is 9.3 ask? Determine the ratio between the largest volume of this cone and the volume of the sphere. So we already have the volume of the cone, right? So we need the volume of the sphere, and then we're going to compare them. So let's see. Right, so let's see what we must do. So let's have a look at what is the volume of my cone. Now the volume of my cone is given as, just see the formula, 1/3 pi r squared h. That's the volume of my cone. So if I look at r, I can substitute it, and r will be equal to, so r squared in this case, 64 minus x squared. And the height of this cone, what is the height of this cone? Well, if I go back to my sketch, somebody's asked us to go back again. Okay, let's go back to the sketch. Let's go back. Let's go back. Just answering someone quickly, so. Okay, let's go back to our okay, let's go back to our problem and just go through it again. Okay, in the light of the one that we just did, this one is quite simplistic, but let's do it anyway. Okay, what is the problem asked us to do? They tell us a cone with a radius r centimeters and the height AB is inscribed in a sphere. So if I think about it, there's a cone inside a sphere. Okay, so the first thing that they ask me is to calculate the volume of a sphere. So they say a cone with radius r and height AB is inscribed in a sphere with center O and radius 8. So if I'm thinking of a sphere, now a sphere is not exactly round, it's more elongated, but they're telling me that the radius of this particular thing, if I look at the sphere, okay, let's go give you the pictures that I am busy with. Okay, let's go this way. Okay, so let's see what I have. I've got a sphere, and the radius of the sphere happens to be 8. So if I look at the volume of a sphere formula, then the volume of a sphere formula is 4/3 pi r cubed, where the radius is 8. So I substitute 4/3 pi r, instead of r I'm going to put 8 and I'm going to cube it. So I end up with my volume as being, because I've done it now just previously, my volume as being 214,66 centimeters cubed. That's the volume of my sphere. Is everybody there? Right, that's the first one. It's a straightforward substitution. Then they say, show that r squared is equal to 64 minus x squared. If you have a good look, there's a small little triangle over here in the sketch. This side here is x, this side here is r, because if I look at my sketch, let's have a look at the sketch again. If I look at my sketch, there's my sketch, line drawn from the center to the circumference, line drawn from the center to the circumference. If this side here is 8, then this side here, which is also a radius of my sphere, will also be 8. So I'm there now. Okay, so now let's go back to our presentation. So this side here is 8. So they ask us to show that r squared is equal to 64 minus x squared. That's my angle, that's my opposite side. So let's use Pythagoras' theorem on the sketch because it is a right angle triangle. So Pythagoras' theorem says the hypotenuse squared is equal to the opposite side squared plus the adjacent side squared. So what is my hypotenuse? My hypotenuse happens to be 8, which has to be squared. My opposite side happens to be x, which has to be squared. And my adjacent side happens to be r, and that's all squared. So therefore, 64 will be equal to x squared plus r squared, and 64 minus x squared will be equal to r squared. That's where I get it. In the next question, they ask me to find the following. So let's look at what they're asking us. In the following, they say, determine the ratio between the large volume of this cone and the volume of the sphere. Now, we've already got the volume of the sphere. We now still need to find the volume of the cone. So let's find the volume of the cone. So, how do I do that? Well, I have a formula for the volume. So the volume is equal to a third, this is of the cone, pi r cubed h. So, v squared, okay? Pi is 1/3, pi. What is the radius squared in this case? The radius squared, I can just go back and I can substitute that. 64 minus x squared times the height. Now, what's the height of this cone? Well, if I look at my cone very carefully, this is what my cone looked like. My whole cone. So from there it was O, this was 8, this was X, this was B, this was R, right? If I look at my cone, very carefully my cone, and I'm just looking at half the cone right now. I'm looking at half my cone right now. I look at half my cone, the height of the cone must be 8 plus X. That's where I get it from. So 8 plus x is the height of my cone. Okay? So there we've got all things as we need it. We've got the radius. Where did I get the radius from? Because I had to, you look at the 8 and the x in my small triangle. If I look at the cone back again, the height of the cone was at distance x plus the 8. So that's where I get 8 plus x. And now all I need to do is multiply out my formula. So 1/3 pi. 64 multiplied by 8 will give me 512. Then I'll get 64x minus 8x squared minus x cubed. So those are the 4 terms that I get. And I've still got my pi divided by my 1/3 pi outside. I notice that they are all unlike terms, so I cannot add them. So I'm going to find the derivative, because if I want to know, or rather, if I want to know what the maximum is, so let's look at the volume, the maximum volume of this one first. So let's find the derivative. So what do I end up with? The derivative of this one will be equal to, I leave the 1/3 pi outside there because there's nothing I can do about it. And I take the others. So the derivative of everything here is going to give me 64 minus 16x minus 3x squared. I take the derivative. Okay. I've got this third in front of it, so can I divide each term by 3? Well, if I divide each term by 3, I'll end up with 64 over 3. I divide by 3, so every one of them will be there. So if I'm I set my derivative equal to 0. So if I set my derivative equal to 0, then 0 is equal to pi over 3 and 64 minus 16x minus 3x squared. Right. I want to get rid of this 3 over here. So what do I do to get rid of that 3? I can multiply by 3 on both sides. So 0 is just going to be equal to 64 pi minus 16 pi x minus 3 pi x squared. That's what I do. Okay. So if I set it equal to 0, and if you want to take pi out as a common factor, that's fine. So if I divide by pi, the same thing will happen. I'm going to end with 0 is equal to 64 minus 16x minus 3x squared. I then have a trinomial that I can go and factorize, and I end up here with 8 minus 3x, and I end up with x plus 8. So x would then be equal to 8 over 3, or x would not be equal to 8. Okay, so that I can't use that particular solution. So x is equal to 8 over 3. So if I want to know what the largest volume, the ratio is between the largest cone and the sphere, I'm going to take the cone and put it on top. So what does it become? So if I look at the volume of the cone divided by the volume of the sphere, so what is the volume of the cone? Well, I think of the volume of a cone, it was, I'm just trying to write it down from where I have it. Volume of a cone. Here we go with the volume of a cone. It was 1/3 pi 64 minus x squared times 8 plus x. That was my volume of my cone divided by the volume of my sphere. And what was the volume of my sphere? It was, oh sorry, I didn't substitute my values. So volume of a cone divided by the volume of the sphere. The volume of the sphere was, let me just see where's the volume of the sphere, was 214.4,66. That was my volume of my sphere. I had to put in 4x. So this was 1/3 pi, and I had to put in all my x values over here. So you would have found that we would have get 514 over 9. In other words, I had to replace x here with 8 over 3. And x here with 8 over 3. Okay? So this one and this one in here gave me 32 over 3. Okay, 24 plus 8 is 32 over 3. Divided by 2144. And I've got a pi over here, so I've got to go back. Because I've got a pi, I can't divide by a whole number, so I've got to use the number with pi in it. And the number with pi in was 2048 pi divided by 3. So let's do that over again. What I have to do is, ladies and gentlemen, my volume of my cone divided by the volume of my sphere is equal to 1/3 pi 514 over 9, 32 over 3. I was just making sure that I did substitute it correctly. And this one was 2048 divided by 3 pi. Okay? I have to change my number back to a pi value for the volume of the sphere because I've got it in terms of pi. So the pi's cancelled. The thirds cancelled. Yes, the thirds cancel. And I'm left here with 8 over 27, which is comma 3. So that is the relationship between the volume and the sphere. Okay? That is my story. The largest volume of the cone and the volume of the sphere. Notice the sphere is still going to be the biggest one. The cone is going to be the smaller one. And that's it. That was it. What was hard about this problem was just to remember, the difficult part of it was to remember that you're going to find x, right? You then substitute it into your formula here. That's why I was counting correctly, that to see if 8 times 3 is 24 plus 8 will give you the 32 over 3. I was making sure that that was true. And this is 64 over 9, and making sure that 64, 8 times 3, 64 is 64 over 9, and I deduct it from 64, and that gives me this. So I was making sure that it is, and I divide both sides. And there we go, ladies and gentlemen. Okay? So that sorts out how to find your volume of the sphere. Now, again, as I said, what was interesting that both these exams had this type of question in. I can't guarantee that it's going to come in again in the exam, but just to take note of it. So this was May, June 2019, and the question paper that we looked at was your 2020 question paper. So those are the questions that we are posed around volume. Now, if I go back, and I go back to our story about calculus, then calculus in itself is not a difficult topic. However, there are certain sections that can become problematic. Now, one of the things that is problematic for many learners is when do we or how do we possibly factorize? So I just want to look at one of those. I just want to make sure that we don't have one of those in so that you are not confounded with a problem like that before I carry on. I just want to check something quickly. Okay, there's a couple of things that I wanted. 9.3. They ask you for a ratio, okay? And I know that I gave you something in terms of a one is to 3. So we got the ratio between the largest volume, okay? So I took the volume of this cone and I divided by the volume of the sphere. The volume of the cone is 1/3 pi. You had to substitute your x, that was 8/3, into your formula. That's where I got this from. 9, sorry. This is over 3. Divided by 2048 pi over 3. The thirds had to cancel, the pi's had to cancel. And then you just use your numbers, your calculator, and it gave you 3. That is the relationship between the two. So if you wanted to say 8:27, you could do that, right? If you wanted to put it strictly in a ratio, this is the cone's volume is to the sphere's volume. Okay? Or you could have put it in the ratio 1:3. Okay? I think this is 1:327. Oh, 1:3. 3. Okay, that's the relationship between the two. You want to strictly put it into a ratio. Okay? So it's 8/27. 8/27. If I simplify as 1:3. That's my ratios. Are you happy now? Okay? Okay, if I go back to the May, I just want to see if I've got this question in your book. There are other questions on calculus. 5.1.2, 514. If I take 64, let me just see what I get. If I take 64 minus 64, you just see 64 minus x squared, which is 8/3 squared. So 64 times 3, you can just give it to you so that I can get it right. 64 times 9. Just to help this child out, we can just see what I get. 64 times 9 minus, this is 576 minus 8/3. So what have I got? Squared. 64. 576 minus 64. 5.2, what have I got? 512. Yeah, right. It is 512 over 9 times by 32 over 3. So 512 times, okay, 32, okay, divided by 27. Divided by 27, 606. Oh, so for that child that said it's 512, yes, it is 512. I've just gone through it again. So it is 512. This is 1/3 pi. 512 over 9 times by 32 over 3. So if we simplify it, divided by 2048. Okay, so the thirds cancel, the pi's cancel for that person that's wanting to see it. So let's see if you're getting what I'm getting. So you will get 606.81 divided by 2048. And I get comma 296. And then this is going to give me comma, probably comma 3. And what did I say is my relationship? I said it is 1:3, and that is the relationship, my dear. Here's the relationship. Okay? For the person that's that thing about 514 and 512, there we go. Okay? Are you satisfied now? Okay, so there's the correction. Please, it's not 514, it's 512. If I divide, I checked it on my calculator again, so there we go. It still stays a comma 3. Okay? But thank you for the correction. Okay, let's go to question number 8. Okay, let's go back. I just want to see where the calculus questions is. Okay, let's just talk about, no, I'm not going back. You'll have to rewind the tape to be able to see where you are now stuck, because we have to move on. I just want to see, there are more questions on this, but I don't see, I'm not picking it up. Just want to see that we don't miss anything. Okay, the question that I want to look at is, I want to look at this question. It says the following. It says, if you must draw a graph. So fx is equal to minus x cubed plus 13x plus 12. I just want us to revise a couple of things. First things first, I want us to draw this particular sketch. It's minus is equal to minus x cubed. How do I draw the sketch? What do I do so that you can actually factorize this thing correctly? Now, one of the things that I noticed is that we don't know how to proceed from here. We don't know what to do, and often we don't understand which factors we can add. Now, ladies and gentlemen, just to show you a couple of things, because I'm actually getting to a point, so don't worry about it. I've got a whole number here. So I can't have x equal to 0 to be a factor. It's not going to work. So I need to find other numbers so that fx becomes 0 to know where the factor lies. So in this case, I have found f of minus 1. So if I substitute minus 1 into here, then let's see what happens. And I end up here with positive 1, negative 13, and positive 12. because negative 1 cubed is negative 1, multiplied by negative is a positive. So this gives me 0. Okay, this is question 8. It should be at the beginning of your question paper. It should have been in here. Somehow there's a page missing, so don't worry about it. All I want to do is I want to find factors. Okay? So, if I'm given the particular question like this, and I need to find the factors, I'm going somewhere, like I said, I want to illustrate a particular point. So, I'm going to substitute. I'm going to find a factor. I can't use 0, and the reason for not using 0 is because there's a constant term over here. So, I'm going to factorize this. So now, ladies and gentlemen, I'm going to get a factor of x equal to minus 1 means x plus 1 is a factor. X plus 1 is a factor. That is what it means. Now, if x plus 1 is a factor, right, then I can now find the rest of the factors by using synthetic division. I can find the rest of the factors by using inspection, like I'm going to do. There are other ways to find the factors, but the fastest for me is to find it by inspection. So what I do is, ladies and gentlemen, I take negative x cubed and I divide it by x. Then I'm going to add on a term, some factor, and I take my last term and I also divide it by the first term over here. Now, if you're not familiar with inspection, do it the way your teacher taught you. Okay, so there are my factors. I'm going to find k. So I normally say negative 1, I multiply these two, plus k must be equal to the original term in x squared. Now there is no term over here in x squared, which means that it will be equal to 0. Okay, because I'm trying to find the middle term. So there are other ways to find it, but I'm not going to go into that way. I'm not just going to do it by inspection. So fx, very simply, if I factorize it, it's x plus 1 minus x squared plus 1 x plus 12. There is my factorization. Now, ladies and gentlemen, once more, if I want the factors on the x-axis, then it means that this minus x squared shouldn't be there. So, I'm going to multiply throughout. I will take out the minus sign as a common factor. I end up with x squared minus x minus 12. So, repeat what I said. I multiply these two. I add k. It must be equal to the original term in x squared. There's no term in x squared, so it's equal to 0. The method is called by inspection. So this I do by inspection. Okay, you must ask your teacher to explain this to you, or you must use synthetic division to be able to find the middle term. Okay, I can't do that with you. Alright, next thing. I can't explain that to you now, because otherwise we won't be able to get done. I'm going to say it again. I can't show you how to do this section. You must ask your teacher to do it. All I'm doing is I'm finding the factors and I want to plot this graph so that we can do things differently. But I cannot do it with you. You're going to have to ask your teacher how to factorize it, because you might have done it using synthetic division. Okay? That's why I'm not explaining it, because the schools teach different methods. Okay. So there I have my factors, and I'm going to factorize as usual. Now this has got nothing to do with the shape of the graph. All this does is it gives me my x-intercepts. Now there's a reason why I'm looking at this problem. Please, I need to just go somewhere. I need to go somewhere with you so that you can understand something very carefully. So, minus 1. Minus 1 is on the x-axis, minus 3 is on the x-axis, and positive 4 is on the x-axis. Those are my 3 x-intercepts. So those are the ones that I note. The other thing that's very important for me to note is that this graph has got a particular shape. Because A is less than 0, this graph will smile and then frown. So this graph looks something to this effect. And it goes through, I think the y-intercept is at positive 12, and then it will go through, y-intercept is at positive 12, and then this graph will somehow peak, and it will go through 4. So this is basically the shape of my graph. Now, what I'm trying to illustrate to you is the following. I need to show you that there's a relationship between your original graph and the graph that you get for the derivative. Now, I know that most teachers don't do this, so I need to show you that there is a relationship between it. If I look for the turning point of this graph, then the turning point I can get by finding the derivative. So let's look for the turning points. So what does turning point tell us? The turning point says that I must find the derivative. So f derivative of x will give me minus 3x squared plus 13. That is my derivative of this graph. Okay. So in other words, ladies and gentlemen, it is still going to give me, if I set it equal to 0, I'm still going to get, I just want to see if my graph is upside down. No, my graph is correct. Alright. Okay. I'm still going to get a quadratic equation. Can you see I've still got a quadratic equation? Even though I might have numbers that are not, it doesn't look suitable, but I still get numbers that are. Okay. So I still get numbers that are. Now the next thing that I want to work at is I need to work at my turning point. So, the turning points of this graph, if I factorize it, I'm going to get quite funny numbers because I'm going to get 3x squared is equal to 13, and x is equal to plus minus the square root of 13 divided by 3. So that's going to be my particular x coordinate. I just want to give you values of it because it does help. I know I've chosen a possibly bad problem, but it's fine. The square root. Okay, the square root of 13 divided by 3. And I get 2,81. So it's going to give me plus minus 2,081. So it's about 2. So that's going to be my x value. Now the most important thing is the following. If I draw this graph, then my x-intercepts of this graph are going to line up. So let me draw the graph for you again. So what did I get? I got minus 3 on this side, I got minus 1 on this side, and I got 4 on this side. So the graph did this. Smiles, goes through 12, and takes a turn up somewhere, and it goes through 4. Now the turns that I got, I think this one is minus 2, whatever, 2,08, and the turn on top here is positive 2,08. Now, all I need you to do is to listen very carefully. So now, ladies and gentlemen, all that I need to do is the turning point, right? The turning point of this graph becomes the x-intercept of my graph here, and this turning point becomes the x-intercept here. Where do I get it from? Because I've had to factorize this equation. Now, remember, this equation is upside down. This equation goes through 13, and it does this. Right. That is what it looks like. So this one here is 0,28. This one here is positive 2,08. That is what I get. Those are my x-intercepts. If I take the derivative again, then I will find the second derivative. How do I find the second derivative? Well, I use the first derivative and I go ahead and I get negative 6x. That is what I get. So I get negative 6x, so I set it equal to 0, and I end up with negative 6x is equal to 0, and so x is equal to 0. So what does that then mean? That then means I get a line equal to 0. This is what my line does. That's the line x equal to 0. Right. So this is the second derivative. This is the first derivative. And this is my original sketch. Now, we are asked questions about increasing and decreasing values. Now, let's talk about increasing values. Where does my original graph increase? If I'm looking for increase, I'm looking for go up. Now I can say to myself, it decreases, decreases, decreases until I get here. Then the function starts to increase. Increase, 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 increase until I get to my turning point. The function then starts to decrease on that side. So if I'm looking at the words, where is my original function increasing? It will increase from this turning point to that turning point. That is where my function is increasing. When is it decreasing? When x is less than negative 2,8, 0,8, or x is larger than the x value, there it will be decreasing. Now, if I look at my first derivative, and this is a very important point. If I look at my first derivative, I can easily see where my function is ascending and where it's descending. It's ascending all the way until it gets there. Then it descends all the way until it gets there. Now, which value have I got over here? X equal to 0. Now, where do I get the x equal to 0? Because that's the turning point of this particular parabola. That's the turning point. So it is an increasing function until x equal to 0, and it's decreasing from x larger than 0. Now, very pertinent in this graph is the following. We often ask the question, where is the function concave up, concave down, and people don't understand. Have a look. What's happening to the function over here? It's concave up. And from there, it's concave down. Now let's compare this to my second derivative. Well, you know the story. If it's on the line, a line graph is on the line, above the x-axis, this thing is positive. Below the x-axis, this thing is negative. So, where is it an increasing function? What's happening to it? It's first negative and then positive. So, what does that mean? It first is an increasing, concave up, then concave down. And this is the solution to this particular question. So, what was my point behind it? My point is, when we're dealing with concavity, right? Think carefully. Original function is decreasing. Then it increases between the two turning points. So on the one side of your first derivative, it will be an increasing function, then it will be a decreasing function. Concave up, concave down. If I look at it here it is first negative and then, is it now right? X is equal to, sorry, I'm blowed. Minus x is equal to 0. Other way around, my line is wrong. Sorry, this line is wrong. It is first negative, so this is what it should look like. It is first positive and then negative, because this one says increasing up, this one is increasing down. Now let's check it to see if I really did it the right way. If second derivative of x is equal to negative 6x, and I put in negative, so I take a value less than 0, x less than 0. So in other words, if I take x equal to minus 1, then I'm going to get an f derivative of x, which is negative 6 multiplied by negative 1, which is positive 6. if I take x, which is larger than 0, then, in other words, a number like x equal to positive 2, then my second derivative is going to be negative 6 multiplied by 2, which is negative 12. So this says that the function is first an increasing function, then it becomes a decreasing function, like I have over here. Can you see how important my first derivative, it already helps me decide, because where the graph is going to turn, that is your point of inflection. So it's a very important concept. Even if you make a mistake here, you can see from your first derivative, your function is increasing, then it's decreasing. So notice how my graph must be drawn. It must be drawn if second derivative of x is equal to negative 6x, and not like I did it in the positive direction. It is in the negative direction, and notice it's first positive because above the line it's positive, below the line it's negative. And lo and behold, this is exactly what I do. If I take values smaller than 0, which is in the middle, it's positive. Look at that. If I take values bigger than 0, then I get a negative solution, which tells me it's first increasing, concave up, and then concave down. And that is what I wanted to illustrate to you. That is how you look at your concavity. Now, it's important for us to understand it. It's important for us to know where to look. And that is one of the questions that the learners get stuck with. So it's important, how do I look at it? What I'm looking for. So if I look at it again, then I'm saying the following. If my graph, for that matter, let's say does this. Let's say my turning point is at -1 and this turning point is at 2. Then what will happen, ladies and gentlemen, for my first derivative? It will be that the x-intercept will be at -1 and the x-intercept will be at 2. So this graph then will look something like this. Let me just explain it to you properly. Right? So that's what I would get. In other words, ladies and gentlemen, if I get the axis of symmetry of this graph, what will be the axis of the symmetry? Well, very simple. The axis of symmetry will simply be x equal to, x1 plus x2 divided by 2, because it's the halfway mark. So it will be -1 plus 2 over 2, which gives me a half. So my x value will be a half, which tells me that if I can put it to you this way, it tells me immediately, ladies and gentlemen, that my point of inflection is at positive a half. So my graph will look something like that. That is what my graph looks like. It will go through a half. If it's positive, the graph is smiling at me, it will always move in the direction of my positive x-axis. So there it is. Now I want to know if this function is increasing or decreasing. Have a look. Well, can you see that from my first derivative, I can already see that the function is decreasing. So decreases on this one and increases from that way. So can you see that my point of inflection, which is at a half? So, in other words, if I introduce values for my second derivative, I will find negative answers. If I put in values bigger than a half, I'm going to find positive values. So this graph is decreasing and then increasing. So we say that this function is concave up. And you can see it's negative, 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 and then it becomes positive. And where's the turning? At a half. So your point of inflection helps you. Where can you see your concavity? Look at your first derivative, and it helps you beautifully to see which side is descending and then ascending. So if it descends and then ascends, we call this concave up. So there you go, ladies and gentlemen. You can actually work out your particular situation. And that is what I wanted to say about calculus today. Right? That's all that I wanted to say about calculus today. I think we should move on to our trigonometry. So just give me a few minutes. Let me just get my stuff sorted to find the trigonometry. So let's go on to trigs. So I forgot, before I do this, can we just go to the exam paper of 2020? I forgot about that one. I wanted to do that and I almost didn't do it. Because that's what I prepared for you today. Let's look at the question in the question paper. Because there was something I wanted to point out to you and work through it very quickly. Okay. Just before, now I just see if it did. Because it seems like some of our questions did not come out. This was question number 8 in the question paper. 2020, question number 8. It didn't print. Question number 8 in the question paper did not print. So somehow I missed it. Okay, I'll give you the question anyway. In the exam paper, there was well, in fact, it does look like the same graph that I was talking about, but it's upside down. Okay. In the paper, they said that the graph of gx is equal to ax cubed plus bx squared plus cx. That was the function given. And then they did this. They said the graph looks something like, goes through 0, and it goes through, okay, this was G. Now the question in the question paper said, the first one said, for which values does Gx increase? And so here's one of those questions that I wanted to ask us. For which values of x does this function increase? This point here was -2, 1, and this point was 2. Now, if I'm looking at a particular function, for which values does x increase? Remember what I did? I said this function is coming down, 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 and it happened to be down, 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 then it goes plus, 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 until it gets to 2, down, down, down. So, the question was, for which values does g of x increase? Now, can you see where the plus signs are? So, where does it increase? It increases, ladies and gentlemen, from -1 until 2. That's where it increases. Now, the next question is 8.2. Write down the point, the x coordinate of the point of inflection. Write down the x coordinate of the point of inflection. Write down the x coordinate of the point of inflection. Now again, ladies and gentlemen, what did I say? I said that from your first graph, you can go immediately to your first derivative, which should give you a parabola. So, even though I don't know what the graph is going to look like, I know the turning points become the x-intercepts. The turning points become the x-intercepts, so there is -1 and there is 2. They become my x-intercepts. There is my graph. Right, now, remember, this graph they say, well, it is smiling and then frowning, so it should actually be, it should be a negative graph. So I've made a mistake, this is not true, because I discarded one of the important information pieces, namely, this graph is smiling and then it's frowning, which means that A here is negative. Now we're going to sort it out in a few minutes to see why A is negative. Right, but I do know so far that this graph shape, because it's smiling and then frowning, that it must be upside down. So I draw the graph. So the graph looks something like this. Here's my graph. Right. Now, as I said to you earlier, the point of inflection, right, is the same as the turning point. This is the point of inflection for my second derivative, g of x, right? But this is also the turning point of g of x, right? So it's the turning point of my original graph. Okay. Yeah, the derivative graph. That's right, is the derivative. Now, how can I find this turning point? I'm going to take my roots and I'm going to add them together. So minus 1 plus 2 over 2, and this gave me a half. So this is where I get the point of inflection from. I want you to notice, so in other words, I'm taking my previous knowledge and realizing that the turning point of my first derivative, right, is the same as the point of inflection for my second derivative. So if I want to draw this graph, because it's a negative graph, I will have positive a half. My graph will look this way. And there we have a half. See? So it will be first an increasing function, ladies and gentlemen, until I get to a half. It's increasing, it's positive. Then it becomes a decreasing function after that. So there we have that particular situation sorted out. Now this is important because this is where we get our lines mixed and where we cause misinterpretation, because we haven't exactly seen that we need to look at our sketch and we need to look at the direction that our sketch is given in. So we get, it is x equal to a half. You see, that is how I find it. Right, now the third question is for me. They ask us for which value of x will the graph be concave down. Now I want to discuss concave down. Which values of x? Which values of x is my graph concave down? Which values of x? Now, like I told you, concave down means it's descending. I said to you, look at your second derivative. Look at the second derivative. Positive, 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 and then negative, negative, negative. So it is concave up, and then it is concave down. Notice, it's positive on this side, and then negative. So the down part, so this is f second derivative of x is larger than 0. F second derivative of x is, no, not f, its name is g, is less than 0. So it's concave up until I get to a half. It's positive. And then it becomes negative from there onwards. In other words, my answer to this question is, where is the sketch concave down? Where is it negative? Can you see it's negative when I start at a half and going to the other side? So x larger than a half is where this particular sketch is concave down. And that is how I get it. Now the last question I want to look at you is, I want to look at, they say g derivative of x is equal to minus 6x squared cubed, no, 6x squared plus 6x plus 12, right? Can I find the equation of my original sketch? So if I look at the original sketch, plus bx plus cx. I've got my derivative there. Now I want to find my original equation. Now if I must compare the two, how do I move forward? Well, I take my given equation and I find the derivative. 3ax squared plus, what was this bx, bx squared. It was bx squared plus 2bx plus c. And lo and behold, I can find my equation. Why? Can you see here? This 3a is in the same spot as negative 6. Because by comparison then, negative 6 is equal to 3a. If I look at my next one, 2b is equal to 6. Because it didn't change when I found the derivative. And c was 12. So let's find it and see if we can. So a would be equal to negative 2. B would be equal to 3. And we find that c is equal to 12. So there I've got all my letters in, and I can find my original equation by comparison. 2x cubed plus 3x squared plus 12x. And there's my original equation. See? I just wanted to look at that. Right. So that's all that I wanted to look at. Just to show you that, ladies and gentlemen, if you want to answer to the question about concavity, where must I look? What is important to me? And that is really what I wanted to discuss. So that's the whole thing of concavity. That ends the question paper. And now we can go and we can look at our trigs. Now, let's talk trig language. What is my concerns and where is it that we must be? Now, unfortunately for you, trigs now counts more marks. So it could be more than 50 or it could be, but it is definitely more than what it was last year. Now, what is my concern with the trigs? Many of us are concerned with double angles. But the double angles is not the issue. The issue is really the elementary things. It's really the basics. That is where the problem lies. The basics is where we must be. In other words, before I can even look at a question that's got a double angle in, I need to cover some of my basic things. And then I need to look at graphs. Because that's another point where people get stuck. So in the trig section, I've started with a particular question and I've just given you something to start with, which is an ordinary sketch. So what is it that I really want to look at? I want to look at this whole thing about double angles, but I also want to look at the trig graphs. Now, if I'm given one like in 5.1, in the triangle MNP, n is equal to 90, and sine of m is equal to 15 over 17. So that tells me then, ladies and gentlemen, I need to draw a triangle, and the triangle's name is MNP because they tell me that n must be 90, and that's P. And then they say sine of m is 15 over 17. So my angle is there. So sine of m is equal to 15 over 17, and this is defined as opposite over hypotenuse. So if I think carefully about it, if my angle is over there, this will be my opposite side. So this then becomes 15, and this side becomes 17 across my 90-degree angle, which means that I need to go and find that side. How do I find it? I find it by using Pythagoras Theorem. That's how I can go and find it, right? But now they ask me to find tan of m. Can I find tan of m? Well, if I want tan of m, I obviously need to find mn. Okay, I need to find nm. So how do I find it? I find it by using my Pythagoras Theorem. So I can go ahead and I can use Pythagoras Theorem and find the length of mn, because I need tan of that particular angle, right? So what do? I go and use my Pythagoras Theorem and I substitute correctly, and I should end up with tan of m. Okay, I'm just checking to see that I'm on the right track. That's question 5. Okay, so let's see how I can do this. So, Pythagoras Theorem, what does he say? He says that the hypotenuse squared is equal to the opposite side squared plus the adjacent side squared. So my hypotenuse in this case is 17. My opposite side is 15, and my adjacent side is the side I need to find. So 17 squared minus 15 squared is equal to my adjacent side squared. Now what is 17 squared? Let's just figure that one out so that you can see that we do work things out. Okay. And I get 289 minus 225, and I end up with 64. 64 is equal to my adjacent side, squared of course, so 8 will be equal to my adjacent side. So there we have, and this adjacent side happens to be MN. Right. Then the next question they ask us, they say the length of NP if MP is 51. So MP is now going to be 51. This side is going to be 51. And we need to find NP. So, I look at the following. If I look at sine of M, it's going to give me NP over MP. If I think of my sketch very carefully, so let's see. This was P, this is N, this is M. I've got the length of this one is 17, the length of this one is 15. I now find the length of that one to be 8. Now they're telling me I must find the length of NP if MP, so they say MP now is going to change to 51A. I don't know, it's something to do with it 17, but I need to find its length in terms of NP. So, if I look at sine of M is going to give me NP over, this one. MP is 51. Did I say MP is 51? Yeah, MP is 51. So, I'm going to find this length in terms of A. So, guess what I'm going to do? I'm going to say that NP is what? NP was equal to 15. Some length in terms of the new measurement, I'm going to use the unit A, over, so sine of P. So NP over MP must be equal to 15A over, and then what did we get? Oh no, and MP was 51, sorry. So NP over 51 must be equal to 15A over, what is it I have? I've got 17A. In other words, I need to find NP in terms of a new length. I introduce the A's to tell me that it is some quantity of that particular length. So all that happens now is NP will be equal to 15 multiplied by 51 over 17. So NP's length is 45. Let me explain this again. If we're looking in terms of proportionality, the proportionality, in other words, I know that sine M has got a particular length, right? But now they're giving me a new length. So all that I've done is, I've put in the length, I'm going to find NP, okay? The length that they're giving me for MP is 51. But the original length of NP was 15. The original length of MP was 17. I used the A to designate that I'm finding it in terms of another length. Therefore, I can find the length of NP. That was very important to me because it's a little bit of proportionality that's stuck into this section of the work. Now, if I look at 5.3, now 5.2 is something that you can do simply by using your deduction, but 5.3 is really where the problem lies. Now, what you need to remember, everyone, is that you need to know your double angles very, very well. Now, in this case, I am looking for patterns. And my whole important thing is, before I can say something is a pattern, I must look for ways in which I can see a pattern. So if I look at the cos expansion, I always call this the cos expansion, because then this tells me it must be cos of x times the cos of y. right? Sign changes. Sign of x, sign of y. You see, this is extremely important that you understand your expansions. Now, if you're a bit confused, you're a bit lost, we do have a formula sheet in here that tells you what your cos expansions is. Cos x, change the sign. It is on your formula sheet. In other words, I've got a formula sheet and it is on there. Right. But if I look at my sine expansion, I remember my sine expansion like this. I say it is sine of the one. I call this the sine cos expansion. You see? And the signs are going to change and then the wording change. If you use sine of x there, you must use cos of x and then sine of y. So these two is my expansion, my basic expansion. Right. Now, I need to follow a pattern. So I need to know these two things. So if I look at my question in question 5.3, it says sine of something, cos of something. Now I check to see, are the angles the same? Bingo. So it's sine cos. So sine cos is this one. Then I go back. Is it got a minus sign or is it got a plus sign? Well, this one has got a plus sign. So therefore, this one's got a plus one. So let's see the other expansion of sine x and cos x. So this one is sine x cos y minus cos x sine y. So if I follow the pattern on the book, it's sine of 240. Let's see, sine 2x plus 40 degrees. Times cos of x plus 30 minus cos 2x plus 40 sine x plus 30. If I look at this expansion, ladies and gentlemen, if I look at this expansion, then this looks exactly like this one. Can you see? So, if I look at cos x, sine x, if I look at the cos x plus 30, so that is my y and this is my x. So sine cos minus cos sine, there is my comparison. Therefore, I'm actually sitting with a function that says whatever was x, 2x plus 40, minus whatever was the y, x minus 30. See? So if I put it in square brackets for you, this is x, this is y. See? So there's my x, there's my y. But I'm not sure, this represents x, this represents y. So if I simplify, ladies and gentlemen, then this just becomes sine of what? 2x minus x gives me x. 40 minus 30 gives me plus 10 degrees. And there is my expansion written the way that they wanted, in one term. So it's by comparison. Now, the general solution. Now, there are 5 ways in which I can find solutions to equations, but I just want to look at how do we find a general solution. So, I have found out that all of this, cos 2x plus 40, whatever and whatever, okay, it gives me x plus 10 degrees. So they asked me to find the general solution of the following. Now let's have a look at our question paper again and go back to it. So I'm now at 5.3.2. So let's see, 5.3.2. I'm now looking at 5.3.2. It says, so I've written it as a single denomination and now they want me to prove this thing here. Now, we've just found the answer to this. And we found it out to be, by comparison, we found it out to be sine of, and I'm going to go back, we found it to be sine of x, wrong one. We found out that this is sine of x plus 10 degrees. So by comparison, ladies and gentlemen, I found it out. So you must do exactly the same. and then you would end up with where I am. So sine of x plus 10 degrees is what this whole thing simplifies to. So they now want us to prove or to find, they want us to find sine of x plus 10 degrees, and they want us to solve it, equal to cos of 2x minus 20 degrees. How do I find this one? How do I go about it, and how do I know what I must do? The first thing that I check is I check to see whether this and this is the same. In other words, I need to have a look to see whether the names are the same, or the sizes of the angles are the same. If both of them were x minus 20, then it would be easy, because then I can just divide by cos or by sine on both sides. No, by cos on both sides. And I'll end up with 10. But unfortunately, I've got a 2x here, which means that I now have to use co-ratios to change these two to look the same. So this cos is going to be rewritten as 90 minus. So sine of x plus 10 degrees must be equal to sine of what? 90 degrees minus 2x minus 20 degrees. Why am I rewriting it? Because the angles are not the same. The one angle is a double angle, and the other angle is a single angle. So I've got it in that way. So I've got 90 degrees minus 2x. So now what do I end up with? Well, I end up with sine of x plus 10 degrees must be equal to sine of 110 degrees minus 2x. That is what I end up with. Right. Now that I've got it that way, the names are the same, so I can drop the names. Now I must ask myself, in which quadrants is sine positive? Sine is positive in my first and in my fourth quadrant. So I'm going to get 110 degrees, no wait, x plus 10 degrees is equal to 110 degrees minus 2x, right? Plus k times 360 degrees. Or so I can solve now. So this becomes 3x is equal to 100 degrees plus k times 360 degrees. So I'm solving just for x. So divide by 3, and x would be equal to 33, 3, okay? Is it plus k times 360 degrees? Let me just see if I'm correct. Sine is positive in the first quadrant, okay? And it's positive in the second quadrant. So it's 90 minus 2x, I got it. Yeah, that is going to be 110 minus 2x is equal to x plus 30, right? So 3x is equal to 100 degrees, so that. And now, okay, so it's there. Or k times 120. That's correct. Okay, the other one that I have is I can also have that I've done the one. Now I must do the other one. So in which quadrant is it also positive? I've got 2x minus 20 degrees. So I've got 3x is equal to 180 degrees, k times 360 degrees. Okay, now, if I want, they asked me for the general solution. Okay, therefore, I've changed it from sine to cos. The sine is positive in the first and in the second quadrant. So therefore, I must also consider this as being 180 degrees minus. So, x plus 10 degrees must be equal to 180 degrees minus 110 minus 2x plus k times 360. See? Because sine is positive in the first and in the second quadrant, not the first and the fourth. I'm thinking of cos. So x plus 10 degrees is equal to, this will give me 70 degrees plus 2x plus k times 360. Right? I'm going to solve. So this 2x comes across. So this is minus x is equal to 70 minus 10, which gives me 60 degrees plus k times 360 degrees. If I multiply by a negative, then x is equal to minus 60 minus k times 360 degrees. And I didn't forget, k is an element of z. So there we go, ladies and gentlemen. There is my two solutions to it. This one here is in the second quad. This one here is in the first quad. Because sine is positive. So there is my two general solutions to the problem. So please notice how I go about solving. There are 5 different ways at least of solving it. But in this case, not only are the names different, but the angles are different. So therefore you cannot go and divide by cos on both sides. You see, you can't divide by cos on both sides because the angles are different. What you need to do is you have to convert by using your co-ratios. Okay, co-ratios means 90 minus 90 plus. So the names are the same, which means equate the two angles. Now it's important for me to know in which quadrants sine is positive. So I can see that sine is positive over there and over there. So therefore I know that I must get a solution in the first quadrant and in the second quadrant. In the first quadrant, it's x plus 10 degrees is equal to exactly how I got it. Right? And I can solve. Notice if I divide by 3, there we go. If I look at your second quadrant, I have to introduce the 180 degrees minus plus k times 360. And then, ladies and gentlemen, I just simplify the left-hand side. There's nothing to divide. It's just that minus 360. Now, why does it become minus 360, ladies and gentlemen? Because I've got minus x is equal to 60 degrees. So if I multiply by a negative sign, everything is influenced. And that allows me to find a general solution. So that's very important to me when I look at my trigonometry. Now, this is one of the questions where we get very stuck, and also a situation where unless we are quite au fait with working the double angles, we do get this one very. Now, again, ladies and gentlemen, I'm not going to look at things that you can find for yourselves. I need to look at things that we have problems with. So, I'm thinking of the exams, and I'm looking at those questions. Now it says, when we look at our graphs, we get very stuck. So let's look at question 6. It says, determine the general solution of cos x minus 30 is equal to 2 sin x. Now, again in that predicament, what do I do? How do I find it? Is it possible for me to divide by x? Is it possible? Which way will I proceed with this particular question? How do I go about this? Okay? So how do I proceed if I get cos x minus 30 is equal to 2 sin x? What do I do? How do I look at that question? How is it possible for me to solve such a question? Now the first things first. Is the variable the same? So I notice, yes, but there's a 2 there. How am I going to get rid of that 2? Angles are different. How do I find the general solution? So what do I do to find the general solution? Can I put them equal to 0? Can I divide by sine on both sides? Will I get the same thing? So the angles are the same. So let's see if I divide by sin x. Can I? Well, if I notice that very carefully, I can't divide by sin x. Why not? Because there's not an x minus 30 in that particular question. X minus 30 is missing in that particular question. So I can't do that. So I need to try another strategy. I need to find my solution quickly to this. Otherwise I must think it through. Okay. So what do I need to do? Can you see that I can't simplify that? I need to get rid of that x minus 30 because I can't use it as it is. So let's see. So I look at, let me just write down the problem, cos x. Yep. Yeah. I'm now there by you. I just want to go back to my screen. Okay. So I'm looking at cos x minus 30 is equal to 2 sine x. So what I said is, I can't just divide both sides by sine x because there's an x minus 30. But I know how to deal with this. Why? This is a double angle. Or not a double angle, and a compound angle. So I need to expand the side first before I can simplify. So cos is my cos rule. So this becomes cos x times by cos 30 degrees. Change the sign. Sin x sine 30 degrees is equal to 2 sine x. Isn't that amazing? Okay? So in other words, I have to remember I can't just divide because I need to find or expand correctly. Yes, I see it's brachius. Okay, which I'm going to do. I'm first going to finish the problem. So what do I do now? So now I simply have to substitute. We know the value of this and we know the value of this. So this is cos x. This is square root of 3 over 2. Square root of 3 over 2 plus sin x. And what is sine of cos x, sin x? Sine of 30 degrees. This is going to give me, sine 30 degrees is going to give me 3 over 2. Let me just check quickly. I just want to see. So 60 degrees. Cos is 1 over 2 square root of 3. So let's see. Sine of 30 degrees. Sine of 30 degrees square root of 3 over 2. Sine of 30 degrees will give me a half. So that will give me, sine of 30 degrees will give me a half times by a half. Okay? Is equal to 2 sine x. Right. So what do I have now? So now I can simplify. So cos x times cos square root of 3 over 2 plus sin x or half sin x minus 2 sin x is equal to 0. Let me put it that way. So cos square root of 3 over 2. This will going to give me, this is minus, so this is going to give me minus 3 over 2 because I've got a half here. Sin x is equal to 0. Now I can take everything over. So cos x. So let me put sine, let me just put it here. Square root of 3 over 2 cos x is going to be equal to 3 over 2 sin x. Okay. Now it is, to get tan, I must, because the names are the same, the angles are the same. What don't you understand about the third step? I substituted your cos 30 degrees and your sin 30 degrees. I substitute cos 30 degrees. Let me just explain again. You've got, the expansion is cos x times cos 30 degrees. You can use your calculator plus sin x times sin 30 degrees. That is it. Is equal to 2 sin x. If you use your calculator, you're going to get that cos x is equal to square root of 3 over 2 plus sin x, and sine of 30 degrees is going to give you a half. Okay? That's where we are, right? Is equal to 2 sine x. Right. If you keep the cos on this side, cos of x times square root of 3 over 2, then this becomes 2 sine x minus a half sine x. There are four halves in 2, and that's how I get 3 over 2 sine x. That's where I get it from. So square root of 3 over 2, because the numbers get written first. That is where you get it from. Same. So it's not, I haven't done anything funny. There's 4 halves in 2, so 4 minus 1 will give me 3 over 2. So now I'm going to get rid of my numbers. So what number do I want to get rid of? I know that cos x and sin x I can compare because the angles are the same, but the names are still different. So I'm going to divide both sides by cos to get it. But first let's get the numbers right. So what do I want? I want to take 3 over 2. I want sine to be on its own. So let's get rid of the 3 over 2. So divide both sides by 3 over 2, which means I'm going to get square root of 3 over 2 cos x divided by 3 over 2 is equal to sine x. That's what I get. So if I invert, cos x must be equal to sine x. Right? So square root of 3 over 3 cos x is equal to sine x. I agree. Let's pause first. Break.